Today we're going to talk about the first kind of probability that you can calculate, called theoretical probability. When all possible outcomes are equally likely, the theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. And we're going to write the probability of an event as P sub that event. So that's going to be written smaller in parentheses just so you can keep track of it. So what I've just said can be shortened into a mathematical sentence, an equation like this. The probability of an event is the number of favorable outcomes compared to the number of possible outcomes. It's the ratio of favorable to total possible. Okay? This is going to be very, very, very important. So make sure you have this, make sure it's bold, make sure it gets a lot of attention. So we're going to use that formula, which I've also put here, to find theoretical probability. Actually might turn out to be simpler than you imagine. So I've got these letter tiles. They spell out explore. There are 7 letter tiles. Let's say you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? Now, to find theoretical probability, we take the number of favorable outcomes, in this case the number of vowels, and we compare that as a ratio to the number of possible outcomes. Well, there are 1, 2, 3 vowels out of 7 letters total. If I reach into a bag, I could choose 7 possible. But if I reach into the bag, I only have 3 possible vowels to choose. Those possible vowels that I can choose are my favorable outcomes. So I can rewrite this equation as what I'm actually looking for with this story. So the probability of finding a vowel is going to be the number of vowels over the total number of letters. Again, I have 3 vowels and 7 total letters. Remember that probability is a number between 0 and 1. This is 3/7. So I can say the probability of choosing a vowel is 3/7, or about 43%. So if I were going to say, is it likely or unlikely to choose a vowel? Well, it's less likely than it is likely. Remember that if they're equally likely or unlikely, that would be 50%. This is less than 50%. So your chance is greater to choose a consonant than a vowel in this case. How about using theoretical probability? Because sometimes you're going to have to find the probability. Other times you're going to be given the probability and you're going to be asked to use it. So the theoretical probability that you choose a green marble from a bag is 3/8. There are 40 marbles in the bag. So how many are green? Well, at this point, this is something we are really familiar with, right? Because we're working with ratios. If a probability is a ratio, then we can use a ratio box to find an unknown value if we're given the probability and the total amount. So just be careful that you label your ratio box appropriately, and this is going to be cake. It's the green marbles out of the total number of marbles. The probability, remember, it's your favorable outcome out of your total. So your favorable is 3 out of 8. So if the probability is 3/8, but there are 40 total, just make sure you set it up green over total and that it fits appropriately. The number of green out of 40 is what we don't know. What we do know is how easy it is to get from 8 to 40 multiplicatively. To get from 8 to 40, we simply multiply by 5. And so all we have to do is multiply 3 by 5. 3 times 5 is 15, so we can very easily state that there are 15 green marbles out of the 40 because we were given the theoretical probability. Now we're going to talk a bit about fairness. An experiment is fair, I should say, if all of its possible outcomes are equally likely. So here are 2 spinners. In this one, It's split into fourths, perfectly into fourths. 2 is there twice, 1 is there twice. It's equally likely for you to land on 1 or 2. It's also equally likely for you to land on blue or red. So this is a fair experiment if you were to spin a spinner on this circle. However, you have something like this, where 1 takes up half of the circle, and then 2 or 3 each take up 25% of the circle. You're more likely to land on 1 than on 2 or 3. This is not going to be a fair experiment if you are spinning a spinner. Okay? So this is fair versus unfair or not fair. We're going to talk a little bit about fairness in these examples. Using a number cube. Okay? Now you're going to want to call it a dice. I won't mention it again like that. Call it what you want. It's a number cube, numbered 1 through 6. There we go. So the number cube is rolled. Determine if the game is fair. If it is not fair, who has a greater probability of winning? Excuse me. In example A, you win if the number is odd. Your friend wins if the number is even. So you have the numbers 1 through 6 on the number cube. If the number is odd, you win. So that would be 1, 3, and 5. So that would be 3 out of the 6, right? The 3 would be your favorable outcomes out of 6 possible outcomes. So that's 50%. Looking good, right? Your friend wins if the number is even. So that's 2, 4, or 6. That's 3 out of the 6 possible outcomes, which is 50%. You have a 50% chance of winning. Your friend has a 50% chance of winning. We can say that this is indeed fair. Okay? Example B. You win if the number is less than 3. So 1 or 2. So that's 2 out of 6. If it is not less than 3, your friend wins. If it is not less than 3, so 3, 4, 5, and 6. 3, 4, 5, 6. So 4/6. Well, we know that this is 33 1/3%, and this is 66.6 repeating percent. You do not have an equal chance of winning here. These are not equally likely. So this is not fair. Okay? Lastly, we are going to use the spinner to determine the theoretical probability of the event. So we are going to, again, calculate theoretical probability, which is the probability of the event is the favorable outcomes divided by the possible outcomes. Okay? And these are numbers. Number of favorable, number of possible. So what is the theoretical probability of spinning red? Well, for all of these questions, there's a possible number of how many outcomes? 1, 2, 3, 4, 5, 6. So for all of these, the total number of possible outcomes is 6. So the probability of spinning red, I've got 6 and 3 that are both red. So I say, well, that's 2 possible outcomes out of 6. That 2/6, I'm going to simplify and say that the probability of finding red is 1/3. Okay? And that's enough. 1/3, it's fair. It can be written as a fraction, a decimal, or a percent. If you want to convert it to a decimal, you're more than welcome. If you want to convert it to a percent, be my guest. I'm going to stick with fractions right now. And then if you're asked on a test or quiz to give it a particular way, make sure you follow the directions. How about spinning a 1? Well, there's only one 1 here, so the probability of spinning a 1 is going to be 1/6. Okay? How about spinning an odd number? Well, there are 1, 2, 3 odd numbers here. So spinning an odd number, so we'll say the probability of an odd is 3/6. So I'm going to say that the probability of odd is going to be 1/2, which would be 50%. It's equally likely for you to get an odd number than as it is an even number on this spinner. How about spinning a multiple of 2? Well, that's a fancy way of saying what's the probability of spinning an even number, right? So I have 2, 4, and 6. Again, the probability of a multiple of 2 is going to be 3 out of 6. So the probability, and I'll write even this time, is 1/2. The number of times out of the favorable outcomes over the possible. How about spinning a number less than 7? I've got 1 through 6 on this spinner. Every single time I spin that spinner, I'm going to get something less than 7, right? 6 out of the 6 times. So the probability that it's less than 7 is going to be 6 out of 6. So the probability is going to equal 1. We can say that we are certain we are going to spin something that's less than a 7 here, right? So the probability is 1. Remember, probabilities include from 0 to 1, including 0 and 1. 1 is included here. And how about the probability of spinning a 7? Well, the probability of spinning a 7 is never going to happen. I can already say this because it's 0 out of 6 times. This simplifies to simply saying the probability of spinning a 7 is 0. It is impossible to spin a 7. And that is theoretical probability.